Hello and welcome to the Unit 1 Section 6 video on solving literal equations. So in the last section we talked all about justifying our steps, and there were 6 justifications we had for each step that we do in solving equations. We had distributive property, combining like terms, and then the 4 properties of equality. Well, those properties are going to be very important to keep in mind because we're only going to be doing those 6 things in this section, but now instead of having just one variable and numbers, we're going to have more than one variable. And there are going to be some cases where we have no numbers at all. And we're going to be asked to solve for one of those variables, and we're going to have to put it in terms of everything else. Okay? And that will make more sense as we go through some of these examples. But as we do these, keep in mind, we're still doing distributing the same way. We're still combining like terms the same way. We're still adding, subtracting, multiplying, and dividing on each side the same way. Okay? So, with all that being said, let's talk about some examples here. So, in this first one, we are asked to solve for W. So, to solve for W, as you know, we're going to just divide each side by 5. And that leaves us with W equals 3. That's very similar to what we've already done. To get W by itself, to undo this multiplication, we have to divide. All right, well, let's try solving for W if we have no numbers. Well, it's going to happen the same way. We're going to divide each side by what we're multiplying W by, and that is L in this case. And I'm writing a lowercase l in script, okay? So that's what this is. So when we do that, you end up with W equals A over L. Let's look at another example. Here we're asked to solve for Y. To get Y by itself, we got to get rid of this 2x. We get rid of 2x just like we would any other way. We're going to subtract 2x from each side. And when we do that, we get Y equals 10 minus 2x. Now y is by itself, this is what y equals, and we have no y's on the right hand side. That's very important. Whatever variable you're solving for, it has to be by itself on one side and it cannot show up on the other side. So let's look at this one. Solve for y on this one. It's going to operate the same way. We want y by itself, so we're going to subtract RT from each side. And when we do, we get y equals W minus RT. Okay, let's look at a few more examples. We are asked to solve for a specific variable, and they tell us which one in each of these problems. So, we have z equals m plus x. We need to solve for x, so we need to get rid of this m that's with the x by subtracting it from both sides. So here there's going to be a little bit of organization that you need to follow. You could do negative m plus z, but I think it's going to be better to put z minus m. That's just a little bit better notation, and that's going to equal our x. If we're solving for a in number 2, we're going to divide each side by c to get that c off of the a. And so G over C is going to be your A. For number 3, we're solving for X. This is going to take a couple of steps. All right, there's no X in this term, so let's go ahead and get rid of this one. So we're going to add 4K to each side. And that leaves us with negative 3X on this side, and then you have 4K plus 1 on this side. Well, we still have this negative 3 attached to the x, so to get rid of the negative 3 that's multiplying by the x, we got to divide. So you divide each side by negative 3. And remember, everything that's on this side, the 4k plus 1, all of that is getting divided by the negative 3. So this would be your answer. X equals 4k plus 1, all divided by negative 3. For number 4, we have to solve for a. So let's get rid of the c. So we're going to subtract c from both sides. and that leaves us with 2a equals negative c minus 2. And then we divide each side by 2 to get rid of the 2. So we have a equals negative c minus 2 all over 2. For number 5, we are going to solve for a. So let's get rid of the b first by subtracting it. Z minus b equals ma, and then we're going to divide by the m to get the a by itself. And so z minus b over m is what is equal to a. And now here we're going to solve for x. So if we're going to solve for x, let's get rid of our y and our c here. So let's start by adding our c to each side, because I think that's the easiest thing to start with. That's g plus c equals y minus x. Now we got to get rid of the minus y. Okay, so we do that on this side, we do that on this side, and we get a g plus c minus y equals negative x. Well, we still got a negative attached to this. So to get rid of that, we can multiply each side by negative 1. And notice I'm saying multiply and not divide. And here's the reason why. If we multiply each side by negative 1, we end up with negative g plus c minus y equals x. Then we can distribute this minus sign to each of these terms. Okay, so let's distribute it to the y first. So negative times a negative gives us a positive y, and then our g and our c become negative. Alternatively, you could have added x to each side and then subtracted g from each side, and that would have gotten you the same thing. All right, for number 7, we're going to solve for x, so let's get rid of y first. So we got z minus y equals mx, and then we're going to divide by m. So z minus y over m equals x. We're solving for x here, so let's multiply each side by y. And we get yu equals xk. And then we're going to divide each side by x. So you get yu over k equals x. Now, in the top, you could have done uy. It doesn't matter. Yu is the same as uy because we're multiplying. All right, number 9 is going to be a little trickier because we got to solve for a. Actually, not that much trickier because we only have one term with a in it. So let's add 4b to each side to get rid of that on that side. So we're going to add 4b. So we get 4b plus u. You could say u plus 4b, it doesn't really matter, equals negative 3a. And then we're going to divide each side by negative 3. So we get 4b plus u over negative 3 equals a. All right, for number 10, we're going to solve for a. So we're going to first add 6 to each side. And that gives us u plus 6 equals b plus 8a. Let's subtract our b on each side. So u minus b plus 6 equals 8a. And then we're going to divide each side by 8. So you get u minus b plus 6 over 8 equals a. For this one, we're solving for x. This one's very easy because all we have to do is divide each side by negative 6, and we'll have x by itself. So x equals n minus 4p over negative 6. And then finally, we are going to take care of solving for a here. So to do that, we're going to add 2 to each side. You get 3a equals negative n plus p plus 2. Divide each side by 3. And let's reorder the top here. Let's do p minus n plus 2 over 3. Okay? Let's make a quick note about 11. Let's go back to 11 really quick. Now, this is not something I'm going to require necessarily, but we can rewrite this so that it looks a little bit nicer. We can move the negative to the top. Okay? If we move the negative to the top, that would give us negative n plus 4p over 6. And then we can move around what the order of the top, and make it look a little nicer. Okay? This is the same as this. We just moved the negative from the denominator to the numerator, or from the bottom to the top. Again, I'm not going to require you to do this. It's your call, but the bottom solution here just looks a little nicer than the top one because you have one less negative sign in it. All right, that's going to do it for this section on solving literal equations. We're going to wrap up the unit in the next section by taking a look at some word problems. We're going to take all of this math that we've been doing with equations, and we're going to apply it to more real-world situations.